Okay, so after watching the little video in your dynamic book online, you're noticing when you look at this, I can easily find out what my roots are. So my roots are, well, first of all, it's to the third degree because there's 3 x's. So there's going to be 3 roots. My roots are going to be -1 and +4. I know that at +4 it's going to bounce off. Let's talk about the end behavior. End behavior is that as x approaches positive infinity, this is going to go up somehow. So I can kind of sketch it, and I can sketch it because I know it's going to bounce. And as x approaches negative infinity this way, I know that it's going to go down somehow. And let's get some points in between. So I'm going to make a table of my x's and my y's. Okay, easiest one to pick would be, oh, I guess you can do -2. Let's do 0. Okay, because I know -1 is 0. I already know that if I plug in -1. So let's plug in 0. So 1/2, let's do our math down here. 1/2 times 1 times -4 squared. What's -4 squared? 16. Good. And what's that answer? 8, right? Good. So I know that at 0, 8, that's a point. Okay, so let's pick another one. I like the even numbers because I can multiply it by 1/2, but I guess since I'm squaring it, I'm always going to have a, not necessarily. Alright, what do we do? What do you want to pick? Let's do +2, why not? Good. So 1/2 times 3, 2 minus 4 is -2. -2 squared is +4. Good. Half of 12 is 6. Ooh, that's a good one too. So 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 2, 6. Good. Another point? Let's do 5. Because you kind of know that one at the end. Okay, so half of 6, and then 5 minus 4 is 1 squared is 1, so half of 6 is 3. So at 5, 1, 2, 3, 3. Okay, and then from here, I can kind of sketch what's happening. Might want to do one negative here, just to make sure I know. Let's do negative what? 2. Alright, so 1/2. -2 plus 1 is -1. -2 minus 4 is -6. -6 squared is +36. So this is going to be -18. Whoa, so that takes a super, when I'm at, what I pick, -2, it takes a super steep jump down. So my guess is wrong, because I got to get to -18. Perfect. So let's check your answers on a calculator, and I'm going to show you how to also find the table. Somebody else in here had said, oh, I could just find the table. Yeah, you can find the table to check your points. Absolutely. Okay, so I'm going to press graph. Notice I was working on this last night, so I had zoomed out. So I'm going to press zoom, zoom, zoom standard. Okay. So I'm like, okay, great. Looks very similar. Check my work. Okay, let's check my table. So you're going to go second, table. There are my table of numbers. So you can check to make sure you did your math right. No negatives here. These are just the positive numbers. Yeah, there we go. Scroll up and see the negatives. Thank you very much. So we're covering local minimum and local maximums of these polynomials. So I'm going to show you how to do it on the calculator. So you're going to plug in the graph. You're going to click graph, and there it is. Okay, so now we're going to use second trace, but instead of 0, you're going to go to minimum. and press enter. Now my minimum is at the highest or the lowest point? Lowest point. So I'm going to go here because that's where I think the lowest point is. And then notice here in my on my calculator it says left bound. So I'm going to go 1 to the left. I'm going to press enter. I'm going to go 2 to the right because I have to pass the center. I'm going to press enter. I'm going to go back to the middle and I press guess, and the answer comes out to be 2. So now that I know that x is 2, it also tells me that y is 2. So my local minimum is 2, 2. So let's just write that down. This is for example 3a. The local min is 2, 2. So here's how you find the local max. Same idea. So here's my graph. I'm going to press second trace. I'm going to go to max. And is max my lowest point or my highest point? Highest. So I can see my graph and I see that this is my highest point. I think it's there. And you don't even need to do second trace max or min, because it's obvious and it's right there that it's x and y. But let's just say it's not at an integer. So I'm going to go 1 to the left. I'm going to enter. 2 to the right. Enter. 1 to the left, back to the middle, guess. And it shows me that my local max is at 0, 6. So moving on to odd and even functions. It's not the degree of the polynomial. We've been doing the degree before. It's the actual entire function. So to know the difference between odd and even, graphically, looking at the pictures, an even function is symmetric around the y-axis. Okay, so if I were to fold it, it would be a reflection on both sides. An odd function is different. It's symmetrical here around the origin. So if I were to rotate it 180 degrees, that's what it would look like. Visually, that's how you know. Mathematically, we have to practice that. So mathematically, when I plug in negative x, it comes out to be the original function. That's an even function. You can kind of tell, because if I plug in a negative, it comes out to be the original. So if this is what the function looks like, and then I plug in all the opposites, it's going to look exactly the same. That's an even function. The odd function, once I plug in a negative for the x, the entire function is negative, which flips it around the origin. Every sign in the original function turns to the opposite. That's how you know that it's odd and even. So it's very much so like checking Descartes' rule of signs. You guys remember that? So it's very similar to that in terms of just plugging in the negative. So let's do some practice problems. Okay, so we're going to do monitoring progress 5, but as a little review, even functions, when you plug in a negative x, comes out to be the original function. It's symmetrical around the y. And odd functions, if you plug in the opposite of x, the entire function is the opposite. And that is symmetrical around the origin. So let's try it. Okay, f of negative x equals negative parentheses negative x squared plus 5. Negative x times negative x, x squared. Opposite of that is negative x squared plus 5. Oh, what do you notice? This function looks like what? Exactly like the original. So what is it, even or odd? Even function. Good job. Okay, let's move on to monitoring progress 6 and 7. Let's plug in the opposite of x equals parentheses opposite of x to the 4th power minus 5 times the opposite of x cubed. Okay, what does this come out to be? X to the 4th. Good. Now this right here, is this positive or negative? Negative. Good. And then there's a negative in front. So it means that plus 5x cubed. Let's look at this. Does it match the original? No. Is every term the opposite of the original? No, it's not. A few people are shaking their heads yes. No, it's not. This is positive x to the fourth. Oh, this is positive x to the fourth. It wasn't changed. So no, it's not. So, guess what? Neither. Yes, that is a possibility. Okay, Modern Progress 7. I'm going to plug in the opposite. 2, opposite of x to the 5th power. This comes out to be negative 2x to the 5th. Good job. So what kind of function is it? It is an odd function.